We will discuss the other four trig functions that we haven't discussed yet. Just like in the previous videos, we would look at the ratios of the triangles. Remember, there was a video I showed you, and that's how we discovered the sine ratio of the y over r will always be the same. The same with the cosine, x over r being the same. Well, we actually have, let's write that in here. You guys will have to fill in your notes. I don't really love the way your book wrote it. So I'm going to write it a little different. Sine, we said that was y over r. Let me make my pencil a little smaller here. It was y over r. Cosine was x over r. Remember, r is the length of the hypotenuse, or if we're talking about a circle, it'll be the radius. Okay, those are two ratios that we're used to. Tangent has another ratio. It is actually, if we don't consider r, and we just do y over x. So it would just be your y value divided by your x value. That actually stays the same too, with the triangle changing like in the last videos. All right, we have three other functions. This is sine, cosine, tangent. That's what we have there. These words are at the top if you would like to see how they're spelled. The sine, if I take that ratio and I flip it over, what we call that is we call cosecant, right here, this word up here, cosecant. And all that is the reciprocal of sine. Remember, reciprocal means take the function and flip it over, right? Take the fraction and flip it over. X over r for cosine, we have secant, that's this word here. Well, secant is just r over x. I just flip it over. And then cotangent is the only one that really, I think, makes sense with words. Those go together. And that one is just x over y. It's tangent flipped over. If we were to take our triangle in that video I made earlier, showing the ratio staying the same as the triangle changes, I hope you remember that. If not, go check out the sine and cosine video. We would see that these three ratios and that ratio that we just introduced, tangent, cosecant, and secant, and cotangent, actually all have the same constant ratio as well. So these are our 6 trig functions that we're going to deal with. We're not going to actually introduce any more. These are the only ones that exist, at least at this level. We are going to study those 6. So we're going to find these ratios. They're going to give us, at least up front, they're going to give us a point on the unit circle. And they want us to find these 6 ratios. So they gave us this one, these points. Remember, this is an x and a y. So if I draw my triangle here, here's my reference angle that we talked about. And then the sides are going to be, okay, they said that it goes over negative 3, radical 3 over 2. So I know the x here, or the bottom of the triangle, is negative radical 3 over 2. We see that right here. And then we also have our y. It's going up, so it's positive. It's 1/2. And then we can see that this circle here, it has a radius of 1, or semicircle rather, has a radius of 1, so that means this is 1. So there's our 3 sides. 1, 1/2, negative rad 3 over 2. Again, surprise, this is a unicircle triangle that comes up, so we get these ratios a lot. Sine, if we remember, sine is y over r. Well, it's r in this case is just going to be a 1. So this is just a 1/2, right? That's my sine. Sine is y over r, but r is 1 in this case. Cosine is x over r, so it's going to be negative radical 3 over 2. And then tangent is going to be, we'll have to work this out. I'm going to do it right below. It's 1/2. And it's going to be divided by, or over, I'm going to do division, 1/2 divided by negative radical rad 3 over 2. Radical rad, that doesn't make sense. Rad 3 over 2. That's something, remember, if I do 2 over 3, this means 2 divided by 3, right? That's all we're doing right there. All right, so if we do that, remember, dividing fractions, I flip and multiply. You can see that the 2's will cancel here, so I'm going to get a negative 1 over rad 3. All right, we're going to rationalize here just to get a nice pretty number. We talk about this, the rationalizing thing, I think we have in class sometimes. If you're in one of my classes, if not, the radical thing actually is an out-of-date method. We don't rationalize. We don't care really if there's a radical in the denominator or not. It actually stems from something called a slide rule, which is how we used to calculate things. We don't use those anymore, so it's okay to have a radical in the denominator. But in this case, most trig books are they're going to rationalize because the values we're going to use to certain values. So if I multiply that out, notice I get negative root 3. But on the bottom, root 3 times root 3 is root 9, which is 3. So this is actually negative root 3 over 3. All right. Now, this is what's great about these other ones. If you know what goes with what, sine goes with cosecant. That's the reason I wrote this. To go from sine to cosecant, all I have to do is flip it over. So it's a 2 over 1, or 2 rather. This next one, I flip. Cosine goes with secant. So to go from there to there, all I do is flip it over. But here in trig, we don't like the radical in the denominator, and it's only for the way it looks. That's really the only reason we want to get used to these values. Okay, so I multiply that out. I got negative 2 root 3 over 3. Okay, cotangent comes from tangent. I just got to flip it over. Here's the deal, though. If I flip that, I'm going to have to rationalize. So instead, I'm going to flip right here instead. Well, if I flip that, that just becomes negative root 3. So there are my 6 values, right? Sine is that, cosine is that, tangent is that, cosecant is 2, secant is that value, and cotangent is negative root 3. So we have found all 6 ratios given that point on the unit circle. It really just comes down to you knowing your ratios for sine, cosine, and tangent, and then flipping them over for the other 3. All right. Let's try. I think I have 2 more here that I want to do in this section. So this one here, the example, they put that point, radical 2 over 2, comma, negative radical 2 over 2. If I think about that, positive x, negative y, my triangle is going to be in the 4th quadrant. So something like that, right? And then we know each side, this is radical 2 over 2. This is negative radical 2 over 2. And it said on the unit circle, so that means my radius is going to be a 1. All right, so we use the same thing based on x's and y's, right? Sine is y over r. R is 1, so that's going to make our lives a little easier. So we get negative radical 2 over 2. For cosine, cosine is x over r, so it's radical 2 over 2. And then tangent is y over x. Well, if I do anything over itself, it's 1. So this would be negative rad 2 over 2 over rad 2 over 2. Well, anything over itself is 1, but it's a negative 1 because of the negative out front. All right, now all we have to do is match them with their reciprocals and flip them. So if I flip that, I get negative 2 over the square root of 2. But I want to rationalize this because I want to get used to certain values. So I get negative 2 rad 2 over 2, which is negative root 2. All right, so that's why we rationalize, because that's a lot easier to work with negative rad 2 than the negative 2 over rad 2. All right, secant goes with cosine. It's the same thing, except for it's going to be positive, root 2. If I flip it over and multiply, I end up with the same thing except for the signs. And then tangent goes with cotangent. I just flip it over. Negative 1 flipped over is negative 1. So we have 6 answers here. There's that one, this one, that one, all of that there, and there. Cool. I guess I practically highlighted everything, but that's okay. So there are 6 ratios. We're going to do this quite a bit. You'll get a point. You'll draw a triangle, find the sides of the triangle, and then find your 6 ratios. There's a table here that I'm going to leave in your notes. The way a lot of books, the way this is approached by a lot of people changes. I think the way it was presented to me in Trig, it was just like, here's your table, memorize it. I have those 3 values that if you'll go back and look at previous videos, and then I'm going to end up making you guys quiz on it and practice on it quite a bit. We don't really need to memorize this whole table. I really just need to memorize the 3 values, right? And that's what we talked about in the unit circle video. I want to memorize those 3 because I can see that at all my angles here, I get those 3 in some capacity, right? Except for my tangents. The tangents aren't going to get that. And then when I flip them over. But the way that we get to our tangent is we just do y over x or sine over cosine, right? We'll talk about that more in a minute. And then tangent is y over x, and then the bottom 3 rows, you're just going to flip over. All right, we're going to get a lot more help within practice problems that I'm going to give you. So let's move on to our last one. Okay, so they want to know the 6 ratios when t equals pi over 3. All right, so I know t is pi over 3. They didn't give me the triangle this time, but I know that pi over 3 is my tall triangle. So if it's my tall triangle, that means this side has to be, not with a highlighter, this side has to be radical 3 over 2, and this side has to be 1/2. Remember, we have those 2 memorized, and pi over 3 is my tall one, so radical 3 is bigger, it has to be going up. And then when these are the case, we put a 1 there. Sine is y, so radical 3 over 2. Cosine is x, which is 1/2, right? And then we can flip those. Let's do tangent actually first. So tangent is going to be y over x, or divided by x. Well, if I follow that, radical 3 over 2, I change this to multiplication, I flip it over, and I get a radical 3. Okay, so let's flip these. Let's use that previous problem. I'm going to zoom out for a moment so things are going to get kind of small. That previous problem, let's scroll up actually rather. When I flipped radical 3 over 2, which was right here, I flipped it and I got that. So 2 radical 3 over 3. I'm not going to rationalize again, because why do more work than we have to? So that problem is 2 rad 3 over 3. 2 rad 3 over 3. 1/2 is very easy when you flip it over. It's a 2. And then if we use our previous problems, when I have a rad 3 in the tangent, let's go look. That problem didn't have it. But this one, when I took rad 3 and I flipped it, I get that one. That's how it's always going to be. If I have rad 3 and I flip it over, I get rad 3 over 3. If I have rad 3 over 3 and I flip it, I'm going to get rad 3. So this answer here, if I flip rad 3, I get rad 3 over 3. All right. So these are going to take a little bit of practice, but they are just definitions. They're just new ratios. These are the only 6 ratios that we will have for triangles.